Hi guys, welcome to ITI1120 Lab 2. Today we will learn the numbers, expressions, assignment statements, functions, and some strings. Let's start. So in today's lab you have two tasks. You can try to do those tasks at home on a paper or online on the Coursera webpage. And besides these two tasks, you have 4 programming exercises. During the lab section, you have to finish these 4 lab exercises. Let's start. You can find the Lab 2 materials in Brightspace in the tab Labs. Under the Lab 2 tab, there is a Lab2 students.zip file. Please download that zip file and unzip it. So before starting, you should know that you have to run Python 3. So make sure that you are running Python 3. This is like when you open the idle shell. Let me open the idle shell. Here, in the bar here, it shows the Python version you are using. So here, for me, I use a Python version 3.9. So make sure you use Python 3. If you don't know how to do this, feel free to ask TAs or check the materials provided in Lab 1. There is an instruction file in Lab 1 about how to open idle. Here are 2 operators in Python. The first operator is the double forward slash. It's called the integer division operator or the floor division operator. The second operator is the % sign. It is called the modulo operator, and it's used to compute the remainder of the integer division. To understand the forward slash operator, you need to understand the floor of a real number firstly. So the floor of a real number is the largest integer that is less than or equal to the real number. Let's try an example. Here, the floor of 3.2 is equal to 3, and the floor of 3.9 is also equal to 3. While you may think that is quite straightforward, just truncate the decimal part, only remain the integer part. Then this is the floor of a real number. But it's not that case. Let's try a negative decimal point. Floor negative 3.5. For this one, it should be -4 rather than -3. Because the floor of a real number is the largest integer that is smaller than or equal to the real number. So be careful with the negative number. So here, let's try. If we use 4 divided by 3, it is an integer division. Then it is like floor. So 4 divided by 3 is like floor 1.3. So it should be 1. Try another example. 10 divided by 4. It should be floor. Sorry, this is the integer division, right? It should be floor 2.5. And it should be 2. This is integer division. Let's try a negative number. Minus 9 divided by 4. It should be floor. Negative 2.25. Be careful this one. It should be negative 3. Okay, this is the integer division part. This is for this operator. Double forward slash operator. Well, if you use 1 slash operator, then the result should be negative 2.25. Yeah, it is the float point division, not the integer division, if you use only a single slash. Okay, the next operator is the percent sign. The percent sign is to calculate the remainder of the integer division. Let's try an example. So negative 10. The remainder of 10 divided by 4. It should be 10 minus 4 times 2 is 2, right? So the formula should be that the dividend minus the divisor times the floor of dividend divided by divisor, right? So here the dividend is 10, the divisor is 4. The floor of 10 divided by 4 is here. The floor is of 10 divided by 4 is 2. You can also modify this as dividend minus divisor times dividend, the integer division divided by the divisor. Okay, we can verify this. Here, I use the idle shell to verify the result. Let's try firstly this one. The integer division of 4 divided by 3, the output is 1, right? And this one, the integer division of negative 9 divided by 4, the output is negative 3. And this one, the remainder of 10 divided by 4, the result is 2. You can try some other expressions in the shell to verify your answer. Okay, this is these two operators. Next part is the task 1. You can find the task 1 in the Lab2 materials. It is called task 1 lab2.pdf. And the task 2, you can try this on the Coursera webpage, or if you have trouble using Coursera, you can use the materials provided in Lab2 named task 2 lab2.pdf. This is for task 2. You can try to answer those questions on paper. Next, the strings. So besides the integer, float, and Boolean objects, we have the integer 1, 2, 3, 4, 5, float 1.3, something like that, Boolean, true or false. Python has another object, which is named string. A string is a sequence of characters between single quotes or double quotes or triple quotes. Like here, this is a string. This is also string. This one is also string. Well, this one is a string, but with blank space. This one is a string with an integer. Strings can be assigned to variables. Here, we assign a string Harry to a variable named S1. This one we assign the string Porter to the variable S2. There are many operations can be applied on strings. For example, when you use the plus sign operator, you can apply this in two strings. The result is a string that is a concatenation of the two. For example, S1 plus S2. Here, S1 plus S2. It is to concatenate these two strings together, which is Harry Potter. Let's try an example. If we assign S1 as hello, S2 as a blank space, S3 as word. We want to do S1 plus S2 plus S3. It is hello, a blank space, word. But be careful that if you try to concatenate a string with an integer, it will cause a syntax error, since the plus sign operator cannot be applied to two numbers. The plus sign operator can only be applied to two numbers or two strings, but not the mix of the two. However, if you make this part as a string, then you can run it without any error. Python also has a multiply operator for strings. It can be applied to a string and an integer, like this. It means to repeat the string 4 times, and the output is also string. Let's try. If we want to concatenate a string with an integer, like this, an integer, a is equal to 1, a string, b is equal to number, plus a blank space in the end. And then I want to like b plus a. There is an error message. We can only concatenate string to string, not integer to string. While here, if we change a to a string, then we run b plus a. Yes, output is correct. You can also try like a is equal to 4, and then we use a multiply b is to repeat b, the string b number with a blank space in the end 4 times. Next part is the programming exercises. Here, pretend that the following 4 programming questions are your assignment 1. Write all your solutions to the following 4 questions in one file called this one, lab2 _prog _solutions.py. You will be instructed to do a similar thing in your assignment 1. And for this lab exercise, you can create a new file and then save the new file. Save as. I will save it to the desktop. Save as this name, lab2 _prog _solutions, and it is a Python file, and with .py. Okay, let's save it. I have this file, then if a question specifies the function name and the name of its parameters, then that same function name and function parameter names must be used when programming your functions. That will be the case in every question in your assignment 1. For example, in the question on the next page, this one, repeater. The function named repeater, and it accepts 3 arguments, s1, s2, n. So here, your function definition must start with define function named repeater, 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 and it accepts 3 arguments, s1, s2, and then you can write the code inside the function. So remember that do not change this part. Do not change the function name, repeater, and also do not change the number of the arguments. Okay. This is today's exercise 1. Write a function called repeater that given 2 strings, s1, s2, and an integer n returns a string that starts with an underscore. Then s1 and s2 alternate n times, then it ends with an underscore. You may know loops, but you can try to not use loops to solve this question. Here is some sample test cases. So here the output is an underscore, then s1, s2, s1, s2, s1, s2. This part repeats 3 times because n is 3 here, and then the string is ended with another underscore. Here you can try the multiplication operator in Python, right? This one. Multiplication, an integer with a string. Then we will repeat the string any number of times. Okay, next exercise is to read the first paragraph of this page on quadratic equation and finding its roots. This website. It talks about quadratic equation. So in quadratic equation looks like this. This one. The function named roots ABC. So in this file, you should name the function as roots, and it accepts 3 arguments ABC. And the function prints a nicely formatted message displaying the equation and its 2 roots. The 2 roots may be the same number. Here in this one, you may assume that A is a non-zero number, which is the first argument is a non-zero number, and A and B and C are such that B squared minus 4AC is a positive number. This is the assumption for this exercise. So why we have this assumption? We can see that if A is equal to 0, then the formula is bx plus c is equal to 0. Right? It is not a quadratic equation. It is just a linear equation. So we assume that A is not equal to 0. And if we want to calculate the roots of the quadratic equation, the formula is this. The roots is calculated by this formula. And here we said that we want to assume that b squared minus 4ac is a positive number. We can see that for this part, if it is a negative number, then the square root of a negative number, it doesn't exist. So here we only consider the real numbers, not complex numbers. So in real numbers, if the b squared minus 4ac is smaller than 0, then the square root of it doesn't exist. So we just assume that this part is a positive number. So this function needs you need to calculate the two rules. Okay, third exercise. Think back on the previous question. Write a function called real roots ABC. So here, the third function should be like real roots A, B, C. It returns true if the quadratic equation with the given three coefficients A and B and C has real roots. Otherwise, it returns false. Recall that roots of a quadratic equation are real if and only if this part is non-negative. Here the requirement is to not use if statements nor loops. Okay, this part, it wants you to check whether the quadratic equation has real roots. You can check based on this formula. If it is a non-negative number, then this function should return true. Otherwise, it returns false. The last exercise. Write a function called reverse x. And the last one should be reverse x. It given a two-digit positive integer x, returns a number with reversed digits. You may assume that x is a two-digit positive integer. The requirement is to not use if statements nor loops. So the hints for this exercise is to think of modular and integer division operators and how they can help. What number should you divide with to get the first digit? Let's see here, if I have a number 27, I want to get the output 72. I will give you a hint. If you use the integer division, divided 27 by 10, then the result is 2, right? If you use the integer division. Then 2 should be this part in the output. But how do you know the 7? It should be the remainder of 27 divided by 10. The remainder of 27 divided by 10 is 7, right? So we get the first integer, we get the second integer, then we combine these two integers. It is our result. This exercise is to test how to use the remainder operator and how to use the modular operator and the integer division operator in Python. Okay, this is for today's 4 exercises. You need to write these 4 functions with exactly the function name, the number of arguments for each function, and these 4 functions should be inside one Python file. If you have any questions, feel free to ask TAs. I think that's all for today. Thanks for listening. Bye.